In this video, we are going to go over probability and fantasy football player performance predictions. Welcome back to my channel, Numerics with Nadia, and let's get into our lesson objectives for today. You guys will learn how probability can be used to estimate player performance in fantasy football using past statistics and simple probability models. And the key concepts in our video today are probability based on historical data, expected value, which is abbreviated EV, and using probability to make better draft and trade decisions. So now let's dive into some key definitions for our lesson today. First off, probability is the likelihood of an event happening expressed as a fraction, decimal, or percentage. Expected value is a weighted average of all possible outcomes where each outcome is multiplied by its probability. So these two equations definitely write down in your notebook. The probability of an event equals the number of favorable outcomes over the total possible outcomes. And for our expected value, EV is the sum of the probability of an outcome times the value of an outcome. Now we'll define our last two terms for our lesson. Number one being our historical statistics or historical stats. Those are past performance data used to estimate probabilities. So examples of this are average points scored by position, average receptions per game. And our last term today is sample size. The number of past games or events analyzed is our sample size. And a key thing to note here is that larger sample sizes give more reliable estimates. So once you guys have these four terms in your notebook, we'll move on to some example problems. Our first example problem is probability from historical statistics, and it says a quarterback has thrown for over 250 yards in 12 out of 16 past games. So we're going to find the probability here. The probability of throwing more than 250 yards would be 12 over 16, which is 0.75 or 75%. And the interpretation of this is that there is a 75% chance that this quarterback will throw for over 250 yards in the next game. So that's example one. Example two is calculating expected value with points. So here it says a running back historically scores 10 points 40% of the games, 15 points 35% of the games, and 25 points 25% of the games. So I've copy pasted from our notes section the expected value formula, and that's what we're going to use here. So if it's 10 points for 40% of the games, we'll convert that percentage into a decimal and then multiply it by 10. So 0.4 times 10. 15 points, 35% of the games would be 0.35 times 15. And then 25 points, 25% of the games would be 0.25 times 25. We know that 0.4 times 10 gives us 4. 0.35 times 15 gives us 5.25, and 0.25 times 25 gives us 6.25. So our interpretation here would be based on history. The running back is expected to average 15.5 points. That wraps up our second example. Now we'll get into our third one, which is combining probabilities. For this example, it says a wide receiver has 60% chance of scoring a touchdown and 80% chance of catching at least 5 passes. If these events are independent, we want to find the probability that the wide receiver is scoring a touchdown and catching at least 5 passes. So we have two events here, and since it's an and, we'll be multiplying the probabilities. So the 60% chance is the same as 0.6, and the 80% chance is the same as 0.8. We know that 0.6 times 0.8 is 0.48 or 48%. So our interpretation is that there is about a 48% chance that both events would happen in the same game. Now for example 4, it's expected value in a risky situation. So a tight end has 50% chance of scoring 2 points, 30% chance of scoring 8 points, and a 20% chance of scoring 15 points. So we're going to find the expected value here, which is that weighted average. So we have 0.5 times 2, 0.3 times 8, and 0.2 times 15. We know 0.5 times 2 is 1, 0.3 times 8 is 2.4, and 0.2 times 15 is 3. When we add these all together, we get 6.4 points. And our interpretation is that the tight end's expected value is 6.4 points. But the variance is high, which could be very high or very low. So that's example 4. Now for example 5, our final example for today, it's adjusting our expected value with new data. So it says a kicker averages 8 points per game, but in games where the offense scores less than 14 points, the kicker averages only 3 points. If the team is projected to have 70% chance of scoring under 14 points, so that's our condition. We have 2 expected values to be adding up here. If the kicker averages 8 points per game, that happens only 30% of the time. Why? Because 70% of the time our new data is that the team is scoring under 14 points. So we'd have 0.7 times 3 plus 0.3 times 8. We know 0.7 times 3 gives us 2.1, 0.3 times 8 gives us 2.4. We have to add these values up. That gives us 4.5. So our interpretation here is adjusting for the opponent's strength reduces the kicker's expected value from 8 to 4.5. And this is useful because a lot of times there is new information. So something to take note of. I hope you guys enjoyed this video. I know it was a little bit different, but I know a lot of you guys like football, so I hope that you liked this different approach for today. If you did like the video, please feel free to like it and share it with a friend. Subscribe if you haven't already. Comment any questions or any other video topics you would like to see down below, and I will see you guys next time.